Matrix multiplication is one of those topics that is a little bit confusing at first, but once you do it a few times and recognize the pattern, it's not that bad. So we just want to look at our two matrices. We're going to look at matrix A, which here we've got a 2 by 3 matrix, and so remember that it's rows by columns. And in matrix B, we've got a 3 by 2. And we're going to look at multiplying A times B versus B times A. So with our first one, we've got A times B. We've got matrix A, which is 2, 1, 3, -7, -2, and 5. And matrix B, we've got 4, 2, -1, 6, 3, and 5. So there is our 2 by 3 and our 3 by 2. So we've got row 1, row 2, and then we've got column 1, and we've got column 2. So the way these work, remember you've got a 2 by 3 and a 3 by 2. These two middle numbers, the columns of matrix A and the rows of matrix B, have to be equal. And then the outside dimensions are what we will get as our resulting matrix. So our product is going to be a 2 by 2 matrix. So then the way this works is we're going to multiply row 1 by column 1, then row 1 by column 2, then row 2 by column 1, and row 2 by column 2. So now, the reason these have to match up, we have to have the same number of terms or entries in our row as we do the number of entries in our column. Because we're going to go 2 times 4, 3 times 2, and -2 times -1. So we're going to take row 1, column 1, and we're going to multiply that together. That's going to be 2 times 4 plus 3 times 2 plus -2 times -1. So we're doing 2 times 4, 3 times 2, and -2 times -1. So it's across and down. And that is going to give us row 1, column 1 in our resulting matrix. So that's going to be 4 times 2 is 8, 3 times 2 is 6, -2 times -1 is +2, and we get 16. Then we'll go row 2, column 1. So that's going to give us row 2, column 1, this entry here. So that's going to be 1 times 4, -7 times 2, plus 5 times -1. So it's row by column. So that's going to be 4 plus -7 times 2 is -14. 5 times -1 is -5. So we end up with -10 minus 5 is -15. Now we're going to do row 1 by column 1, or by column 2, I'm sorry. That's going to give us this entry. So now we're looking at row 1 by column 2. So that's going to be 2 times 6 plus 3 times 3, and then negative 2 times 5. That's 12 plus 9 plus negative 10, which will be 11. Then we do row 2, column 2. And so now we're looking at this row by this column. So we're going to go 1 times 6 negative 7 times 3 and then 5 times 5. So that's 6 plus negative 21 plus 25. So that would be 4 plus 6 is 10. So that is the product of matrix A times matrix B. Now if we switch that around, let's get rid of, if we switch that around and we want to find B times A, that's going to be 4, 2, negative 1, 6, 3, 5, which is a 3 by 2 matrix. And then we've got 2, 1, 3, negative 7, negative 2, 5. That is a 2 by 3. So now the insides match. The outsides determine our dimensions. So we're going to end up with a 3 by 3. So we're going to have row 1, row 2, row 3, column 1, column 2, column 3. So we're going to do the same thing now, only it's 3 rows by 3 columns. And we're going to go 4 times 2, 6 times 1. So row 1, column 1, 4 times 2, plus 6 times 1 gives us 8 plus 6, which is 14. We'll go row 2, column 1, 2 times 2, three times 1 gives us 4 plus 3, which is 7. And then we've got row 3, column 1, negative 1 times 2, and then 5 times 1 gives us negative 2 plus 5, which is 3. Now we'll do the same thing with row 2, or row 1, column 2, confusing myself. Row 2, column 2, and row 3, column 2. So these I'm just going to say out. So we'll go row 1, 4 times 3 is 12. 6 times negative 7 is negative 42. So that's going to be negative 30. Then we've got 2 times 3 is 6. 3 times negative 7 is negative 21. So that'll be negative 15. Negative 1 times 3 is negative 3. 5 times negative 7 is negative 35. So we get negative 38. And then we'll do row 1, row 2, row 3, column 3, which is going to be 4 times negative 2 is negative 8. 6 times 5 is 30. So that will be negative 22. 2 times negative 2 is negative 4. 3 times 5 is 15. Negative 1 times negative 2 is positive 2. 5 times 5 is 25. And we get 27. So changing the order in which we multiply changes the final product of our two matrices. So A times B is different than B times A. So summary here. Remember that the columns of your first matrix must match the rows of your second matrix. You're multiplying rows by columns. And we're adding the product of the entries. I hope that helps with a reminder on matrix multiplication. If you enjoyed this, please subscribe and watch for more videos.